Suppose this is a sphere, okay, of radius r. Okay, centered at O and radius is r. Okay, is 0 comma 0 comma 0. Now let me draw axis also. Suppose this is y-axis, this is z-axis, this is x-axis. Okay, this is origin. So this coordinate will be this y-axis, so it will be 0 comma r comma 0, and this will be 0 comma 0 comma r, and this will be r comma 0 comma 0. Correct? Okay. Well, if I ask you to find the volume of this sphere, how you will find it? Well, you will apply triple integral dx, dy, and dz, right? Like this you will solve. But in that we use something called as spherical coordinates. How you apply that thing? I mean, you know that you assume z as r cos theta, x as r sin theta sin phi, y as r sin theta cos phi. But why do we assume it like this? Many people ask me. So for to clear this idea, I'm making this video, right? So let me explain it how it works actually. Okay. So suppose this is a point on the surface of a sphere. There is a position vector r. Okay. Now what will be the coordinate of this point? Well, let's see. Suppose this is angle theta. Okay. This is r vector. So this will be r cos theta, right? And now since now r is not on yz plane, it is, suppose this is yz plane. Suppose whatever. Suppose this is yz plane, okay, and it is going like this. Suppose this is yz plane and it is going outside or inside, wherever you want, okay, but it is not on yz plane, okay. So this and the component on y plane will be r sin theta, okay. Now assume this as phi, this angle is phi, okay. Now it's totally on you, whatever you want to take, you can take whatever angle you want. I have taken this as theta, this is phi. I have taken this as x, this is y, this is z. So this is not necessarily true that this will be always true. No, it's totally on you how you assume it. But in general, we assume it like this only. The z-axis is like this. We are rotating about the z-axis basically over here, right? So that is why we take it like this. Okay. Similarly for the sphere also, for the cylinder also, we get somewhat like this only, okay, but that's the story for another lecture. Okay, so this is what we get now. Yeah, now let's take the component of r sin theta. So what we'll get, this will be r sin theta cos phi, this is along y, and along x it will be r sin theta sin phi, right? So what will the coordinates now? It will be r sin theta sin phi, r sin theta cos phi, and r cos theta. Okay, so this is the coordinate of this point. Okay, correct. Now if you want to check that is it even correct or not, we can check it also. How you will check? R vector is r sin theta sin phi I cap plus r sin theta cos phi j cap plus r cos theta k. Now if you take the magnitude on both sides, what you will get? You will get square root of sin square theta sin square phi sin square phi, sorry, plus r square sin square theta cos square phi plus r square cos square theta. It will turn out to be equal to r. How? R square will be taken common, that's obvious. Whereas sin square theta into sin square phi plus sin square theta into cos square phi. So you can take sin square theta as common. You get sin square theta times sin square phi plus cos square phi, which is equal to 1. So you will have sin square theta plus cos square theta, which is again equal to 1. So the magnitude turns out to be r only, which is the magnitude of this only, of this r vector. Correct? Okay. So this is the coordinate of this random point. Okay. Right. Now suppose, so this is how you take the coordinate of this random point over here. Suppose let's name it as P. Okay. Now if I ask you to find the volume of this sphere, how you will find it? Well, what are the parameters which are affecting this sphere? Can you name it? Well, if I change the radius of this sphere, will the volume change? Of course, it's obvious, right? So if I change the radius from r to r plus dr, now this dr can be positive or negative, whatever you want. If you want to decrease the volume, then it will be negative, and it can be positive if you want to increase the volume of the sphere. Correct? Okay. So r turns to r plus dr. So this dr is the is the radial length. Okay. This is a length. Okay. Now suppose in this I need to use another chalk because else it won't be clear. Okay, just a minute, just 1 minute. Yeah. So suppose I shift this point a bit. By an angle d theta. Okay. Correct? Okay. Now, what will happen? What will the length of this arc? Radius is r, angle is d theta. So r will be equal to polar length. Sorry, polar arc, because it's an arc. Correct? Okay. Now, similarly, if I change this point, this will be d phi. Correct? This will be d phi. This length is r sine theta. And now, if I see this, what will be the length of this arc? This is called the azimuthal arc, right? These are the three factors, I mean dr, d theta and d phi. These are the three factors which can affect the volume, and these are the radial and polar and azimuthal arc. Okay. Depending on these arc and length, the volume of a sphere will change, right? So you can clearly say that the volume of this sphere will be triple integral of r square sine theta d r d theta d phi. Correct? Okay. Now, of course, r will go from 0 to r. That's obvious. D theta, it's an arc. Suppose this is the point. This is a semicircular arc actually. Of course, this is not there. This is a semicircular arc, right? going from this angle is going from 0 to pi, correct? Y 0 to 2 pi and y 0 to pi. So it was going from 0 to pi, right? You got when this angle goes from 0 to pi, you get a semicircular arc. Okay, so you will get this region, this semicircular arc you will get. Okay, correct. Now there is a semicircular arc like this, and if I start rotating it, what you will get? You will get a sphere. And if I rotate it by what angle? By 2 pi, by 360 degree. Because if I rotate only 180 degree, what I will get? I will just get a hemisphere. But if I rotate it by 360 degree, I will get complete sphere, right? So that is why phi will go from 0 to 2 pi and theta will go from 0 to pi, right? Now just evaluate this. Integral of r square dr will be r cube by 3. The integral of d theta sin theta d theta will be equal to, from 0 to pi it will be equal to 2. You can check it, 2. And integral from 0 to 2 pi of the function of this d phi, it will be equal to 2 pi. So you will get 4 pi r cube by 3. This is the volume of this sphere, correct? Okay, so this is how you calculate the volume of the sphere, and that is how you get spherical coordinates. Okay, so if you learned something new from this video, please do like, share, subscribe, and please support this video. And one more thing which I need to tell you, that r square theta is the Jacobian which you will get when you will move from dx, dy, dz to this. You can check it yourself. So this is basically a direct proof of Jacobian also from here. So if you enjoyed this video, then please do like, share, subscribe, and please support this video. Bye bye, take care.